like debates were happening. Students were super into it. They were like, every time I get new evidence, my hypothesis keeps changing. And I was like, yeah, yeah, that's science. That's science. This is great. Inquiry-based lessons can be tough. It feels like they are time suck, but they don't have to be. They can be just a regular part of your lesson. I'm going to walk you through a way that you can make cellular respiration an inquiry activity. And I'm going to provide you two different ways that you can integrate it into the 5 E's if that you use the 5 E model in your school building. So let's get into it. It's called murder or coincidence. And the phenomenon that we're looking at for this is the Chicago Tylenol murders in 1982. It works really well as an explore activity or as a like elaborate activity towards the end of the unit. You can use it either way. And I'll talk through both ways it can be used as we go through it. So when you get it, it pops up like this so that you can confirm it's the right activity that you've opened. And you click use template, which will make a copy. But what's nice, at least for me, which might just be me being a little bit anal, is that when it copies, it doesn't put that copy of at the front. That drives me up the wall. It might not bother anybody else, but it upsets me. So I figured out that it wouldn't do that for you. There is the key. Make sure you delete that before you post it to your for your student. And so speaker notes have little hints as students need. So providing us a little bit of scaffolding. And I also link a diagram of cellular respiration that students can use. However, you can also delete that out if you don't want your students to have access to it, if you want them to be doing it off memory. So that would be more so if this was an activity they were doing in their elaborate phase. If that's the case, I would suggest asking students to draw a model of cellular respiration before they start. You can have them do it from memory and then use their notes to confirm that it is accurate. And then let them use the model that they've drawn as they go through the activity. And then if this is an explore, give students a model of cellular respiration. Depending on how much work y'all have done on analyzing and annotating models already, either have them annotate and analyze the model themselves or do that whole class. And just to not to go into a whole lot of detail about cellular respiration with them, more so to just make sure that they hit the high points, that they're noticing what the inputs and outputs are and what the three phases are of the 3 steps of cellular respiration are. Okay, so this starts with your student handy dandy, a medical examiner's assistant popping in and, updating them on what's going on. Then your students are going to read through these 7 cases of mysterious death that have occurred. And so they're wondering, they all happen in the same neighborhood. So your student is tasked with investigating these 7 deaths and figuring out are these connected deaths, or is it just a coincidence that all 7 of these people happen to pass away in the same neighborhood within a relatively short period of time? And so they're going to start with just having read the crime scene notes, identifying what, if any, similarities there were, what the symptoms were, and then coming up with this initial hypothesis. And this initial hypothesis is really important because it's going to teach students to think through. This initial hypothesis is going to be important because as students go through the activity, they are going to be updating what their hypothesis is. And this is a part of teaching them the nature of science. That science is ever changing and ever updating as they get new data. So first, we're going to get this initial autopsy report and get the cause of death and this other information. And they are going to need to look at that in order to determine did the victims have enough oxygen in their blood? At first glance, they're going to be like, of course not. They died from a lack of oxygen. But if they pay attention to the last bullet point, they will note that the oxygen levels in the blood were 100 milligrams and the normal range is 75 to 100 milligrams. So they had a normal amount of oxygen in their blood. And on the next slide, it confirms that they are correct. And so how is it possible that they died of hypoxia when their blood had normal oxygen levels? And what they should note here is that the mitochondria were greatly damaged. And the mitochondria is the actual organelle that is using the oxygen. So, yes, when we breathe in, it is to live, but specifically, the way that oxygen helps us live is because the mitochondria uses it to make ATP energy that our bodies can use for us to be able to do all the things. And so those damaged mitochondria would explain how their oxygen levels were normal, but they died from lack of oxygen. So essentially, they have the oxygen in their blood, the oxygen is being delivered to the cells, but the cells aren't able to utilize it because the mitochondria is damaged. And then the assistant again is coming back and it's like, I'm running this blood sugar test you're asking me to run. What's they got to do with any of this? And essentially what's happening here, we're thinking about here, what this is getting at is the first step of cellular respiration is glycolysis. And so if in glycolysis, the input is glucose or sugar. And so if there is no sugar in the blood, then if blood sugar levels were abnormal, that could explain why oxygen levels could be normal, but somebody could still essentially die from not having enough ATP in their body. And so that is what we're getting at here. And the next one, it says the cells are producing carbon dioxide, but ATP levels are very low. And so looking back at this model, it shows them that the Krebs cycle has carbon dioxide as an output. And so that lets them know that, oh, well, if the carbon dioxide was still present, then the Krebs cycle must have at least kind of been happening. ATP levels are low. Glycolysis only produces a couple of ATP. Krebs cycle only produces a couple of ATP. The bulk of ATP are produced in the electron transport chain. And so the lower ATP levels are a red flag that something must have happened with the electron transport chain. So with this information now under our belt, our students are going to look at the toxins that could potentially be causing these symptoms. And so they're going to look at how each toxin could potentially affect cellular respiration. Carbon monoxide prevents oxygen from binding, so that would be affecting the electron transport chain. Too much insulin causes a drop in blood sugar levels, which will be impacting glycolysis because it wouldn't have the input that it needed. Cyanide prevents the mitochondria from absorbing oxygen. And chlorine gas causes the lungs to swell and become unable to absorb oxygen. So the answer here, of course, is going to be cyanide. With the carbon monoxide and the chlorine gas, the oxygen is never actually making it to the cells. And so we would expect to see low oxygen levels in the blood, which is not a match to what we saw in the evidence. In the insulin overdose, we checked earlier and the blood glucose levels were normal. And so the students go through and explain, and they go back to the initial evidence and those case summaries to determine how the victims must have come in contact with the toxin. And it comes to a conclusion about whether this was a tragic coincidence or purposeful poisoning. And in addition to like basically running through a review of cellular respiration and really getting students familiar with the 3 different parts of cellular respiration, this activity is going to make students use their critical thinking skills, make them engage in some analysis. And like kids like true crime, just like adults do. And so it's a really good hook. And then if you have kids that are curious, they can go on the last slide. It tells them, it links to the actual Chicago History Museum. So they can learn about the true story that this is based on, which is the Chicago Tylenol murders. Great. And like, even before they got into it at all, just like seeing the cover page of it, like being murder or coincidence, I have some students who were like, oh yeah, I love true crime. I'm ready. And so it went so well. Even some of my students who at the time really didn't engage much on anything were invested and were like raising their hand, asking me questions, giving me their theories. So truly can't recommend this activity enough. I will link in the description where you can purchase it. Let me know if this like walkthrough is helpful. Let me know if this walkthrough was helpful. If I should do it for more activities. If you give me some feedback on that in the comments, it'll be super helpful. Let me know what other resources you would like me to do a walkthrough for, and I'll talk to y'all soon. Stay curious.